Hey everybody, today we are going to do an awesome physics lab. Has to do with conservation of energy. So get pumped. You guys get to play with these little alien toys. Alright, so let's get focused. Put away your phone. Yes, put that phone away. Okay, let's get focused. We are going to conservation of energy these things today. Okay, so what type of energy do I have right here? All right, I just loaded a spring. Okay, I got spring potential is the answer. Okay, then this thing is going to pop and you're going to have kinetic energy at the bottom. Its fastest speed is going to be right at the bottom. Then up here, what type of energy do I have at the top? You know it. Okay, now, measuring in this lab is kind of tricky because you're measuring a moving object. So the things we're going to change in this lab are mass. Okay, got the balance right here for you. You can mass this out. And then we're going to add pennies to the alien's head using tape. Okay, and you're just going to keep adding pennies, and then what's going to happen to the height? It's no stunner. It's not going to go as high. All right, so measuring the height that it goes. Here's a hint. Use your technology that you have. Yeah, I just told you to put your phones away, and now I'm telling you to get them back out. Okay, so you're going to use your phones and maybe some slow-mo camera stuff. All right, hopefully you have some storage on your phones to get different heights from different masses. All right, let's take a look at the handout. All right, you got the informal toy lab. All right, and we're going to derive an expression for height in terms of these things. Okay, so we're going to start out like this. We're going to start out by saying EI equals EF, just like any other conservation of energy problem. Okay, what do I have to start? I have potential energy stored in a spring. At the top, that's my final position, I have potential energy due to gravity. Okay, now use the equations for these. I'm going to let you take it from there. And then you're going to have to describe what to graph where to get a slope that will help you find K. All right, and this is going to be kind of tricky, what to graph where, but you guys can figure it out. You're smart. Okay, down here we're going to rearrange the equation in y equals mx plus b format. There is not going to be a plus b today. Here's space for you to take any data that you need to take, your graph, and then your analysis of slope to get K. All right, so we've already done another lab where we took a spring, okay, and we fixed the top, and then we simply hung masses from it, and by measuring the stretch distance, we got K. All right, in this lab, we are going to use energy to get K. And then we'll actually do a third lab later in the spring that uses another method to find spring constant. Okay, now review on a spring constant. Spring constant is how many newtons it takes to compress it 1 meter. Okay, now today you're not going to be compressing this 1 meter. Each time you're going to compress it is just that little distance, and you're going to have to measure that. That's one of your constants in the experiment. This compression distance does not change. All right, so good luck to you and your group. Hope you guys have a good time. There's lots of fun aliens to play with. Look at all these choices. I mean, really. Okay, so get pumped and have a good lab.